Let's talk about unit rate and finding unit rate when we're dealing with fractions. If you will recall, a unit rate is a rate where the second quantity is 1. And what we've been doing up until now, for the most part, is in order to get the unit rate, we've essentially been dividing the numerator and the denominator, or both numbers in our ratio table, by that second quantity, because a number divided by itself is going to be 1. Since we're dealing with fractions, it's going to be a little bit different. So let's take a look at this. Okay, we have an example here. A top swimmer would be able to swim across a 25-meter pool in about 1/5 of a minute. How fast can a top swimmer go? Okay, so let's look what's important here, okay? The distance is going to be 25 meters, and the time is going to be 1/5 of a minute. Okay, and so when they say how fast can a top swimmer go, they're looking for speed or unit rate. Okay, so I'm going to make my ratio table here, and you can see that we're comparing meters to minutes. Okay, and from the problem, I get that the number of meters is 25, and the number of minutes is 1/5. Well, in order to get a speed or a unit rate, my second quantity, or the minutes, has to be 1. So, what do I have to do to 1/5 to get 1? Well, I have to multiply that by 5, right? Because 5/5 is equal to 1 whole. Have to do the same thing up here because there's nothing different about this other than the fact that we're dealing with a fraction. 25 times 5 is 125. And so, how fast can a top swimmer go? A top swimmer can go 125 meters per minute. Now, in this case, if you like, you can deal with this as a decimal. So if we're doing meters to minutes, it's 25 meters in 1/5 of a minute, or 0.2 minutes. And then you're going to proceed the same way. Okay, times 5 is going to give you 1.0. And times 5 is going to give you 125. All right, so that brings us right back to a speed of 125 meters per minute. And you'll notice here we have to multiply to get the rate per minute instead of dividing, which is what we would do if we were dealing with whole numbers. All right, let's look at another example. Okay, using her garden hose, Camilla filled up a 4-gallon bucket in just 1/6 of a minute. At what rate does the water flow through the hose? Again, 4 gallons is what we're interested in, and the time is 1/6 of a minute. Okay, now you might want to think about this and use your common sense. If she filled a 4-gallon bucket in 1/6 of a minute, and we're looking for how much she could fill in 1 whole minute, would that be more or less than 4 gallons? Okay, so if you think about it, you should come up with the notion that she should be able to fill up more than 4 gallons because she has a whole minute as opposed to just 1/6 of a minute. All right, so here I'm going to use fractions. All right, so I'm going to do 4 gallons. And I know it's going to look kind of weird, in 1/6 of a minute. And so I want her rate in minutes. So I need to see what this equals in 1 minute. Okay, now I know I have to multiply. I'm going to put my fraction box here. This has to equal 1. Well, what do I have to multiply 1/6 by to get 1 whole? I have to multiply it by 6 because 6/6 is 1 whole. And so I have to do the same thing up here. 6 times 4 is 24. And here is your answer. You can leave it like this, 24 gallons in 1 minute, or you can write 24 gallons per minute. And again, that agrees with our very rough estimate, which was that she could fill more than 4 gallons if given a whole minute. All right, now let's look at one last problem. Jen rode her bike 1/8 of a mile to her friend's house. It took her 5 minutes to get there. What was Jen's speed? Okay, again, we're looking for per minute, right? And we have that it took her 5 minutes and she rode 1/8 of a mile. Now, what makes this problem different than the other two? If we look at it, let's do a ratio table. Okay, and we are comparing miles to minutes. Okay, and let's fill in directly from our problem. Okay, we have 5 minutes and 1/8 of a mile. So do you see that in this case, the thing that makes it different is we have a whole number of minutes, but our distance is the fraction. So we're going to treat this the way we used to treat, well, we still do. Whenever our denominator is a whole number, we need to get to 1, right? So in this case, we do have to divide. What do we divide by? We divide by 5, okay? And so we have to divide this by 5 as well. Well, let me see. What am I going to do? I'm going to have to take this out of the table to do my math, because I want to do 1/8 divided by 5, and I'm going to write it as 5 over 1. How do I divide fractions? Oh, well, I have to multiply by the reciprocal, right? And the reciprocal is 1/5. And so I get 1 over 8 times 5 is 40. And so 1/40th, all right? So what is her speed? Her speed is 1/40th of a mile per minute. It's not very fast, is it? But, well, maybe you have to teach Jen how to ride her bike a little bit faster, but still be careful. Okay? And again, does it make sense? Yes, because if she only goes 1/8 of a mile in 5 minutes, well, if she only rides for 1 minute, she's going to be riding even less, right? So that's how we kind of want to check. We want to make sure that our answer makes sense. And again, all of this understanding and this being able to solve these problems with fractions, don't be intimidated by the fraction. Just go into your ratio table, into your equivalent fractions, and keep in mind always that when you're doing unit rate, your answer is going to be per minute, per hour, per day. And so you want that second quantity always to be